Good afternoon and welcome to the session about large tables, very large tables in SQL Server. This is after lunch session, so I will talk about statistics. It's a great thing to sleep a bit. I'm Milos. I'm head of MS SQL database engineering at Entain. Entain is a global company, online betting, the largest online betting and gaming company, but I'm located in Austria, in Vienna. And I used to be conference speaker, go out of three books. This year should be fourth one. The most important thing from this slide is my email address and LinkedIn handle if you have questions about this session or general about SQL Server. If I don't know, I know people who will who know more about SQL Server. At Entain, I work with large tables. That's the reason why I present this session. Session feedback, you can. There's a QR code for session feedback. You can load it and please give me a feedback. I mean, you can do it right now before I make something, but you can do this later. I'm not sure I have this slide at the end of the session, so maybe I will not reach to the other end of the slide. So please do feedback. It's a great thing for speakers, for organizers, and so on. Okay, dealing with very large tables. What is a very large table? This is a table where you see something you don't see by other tables. No, sometimes you talk to women like this. I never feel this before. This is a very large table and they require special attention. And as a rule of thumb, we can say it's 100 million rows, but that depends on table size, column size, and all these things. But basically, we talk about large tables if it's, I don't know, sometimes 10 million, 100 million rows. Which challenges we have with very large tables? Maintenance challenges are having and performance. As you can see here, I will talk about performance. I will not talk about maintenance. I will not talk about partitioning. This is not talk about partitioning. If you expect partitioning and only partitioning from this session, it's time now to switch on to go to some other session. But I would highly recommend sessions from Uwe Ricken, from Maggie Naumova. I wanted to recommend Maggie Naumova's session in my talk, but this session was on Wednesday. There is a big problem. It was already, but you can find videos from previous SQL Bits conferences, other conferences about partitioning. I will not talk about partitioning. And there is no out-of-box archiving solution within a SQL Server. It would be nice to have it. If somebody from Microsoft is here, again, I would repeat, it would be nice to have this solution. And the most important reason why we have large tables is because we do not delete data. We don't need, in many cases, we don't need such large tables, but we do not delete data. And we were told that we need to retain data for 7 years or for 10 years or forever, but nobody told us to leave it, to keep it in the same table. But it's the easiest way to keep data in the same table. You don't need to do anything, just to buy storage and everything is there. And most of us, I can tell pretty freely for everyone here, that we work with large tables. If we work with large tables, we operate with maybe less than 1% of data. All the other data we don't need, but we index them, we backup them, we restore them, we have them, we maintain them, but we don't need them. And since there is no out-of-box solution, in most cases that means there is no solution. We need to buy to make our own solution. And the good thing with large tables, before they become large, you need to think about archiving. If you don't think about archiving, if you try to make it later, you will never do this. Good. So another problem is all-link problem. So if you do not archive, people will also ask questions against this table. You will have reports in the same table. You have OLTP on the same table, and it's a big challenge. This thing cannot scale. So all these problems we have very, very large tables, but I will talk about performance. So my expertise, performance tuning, performance troubleshooting. If you have large tables and performance problem with large tables, you can bring server down. 3 things are important. There are many things, but 3 most important things with performance are indexes, how we write queries, and the third, cardinality estimation issues with large tables. First 2 appear with all tables, with small and moderate tables, and the third one is related to very large tables. Okay, missing index. I have a question for you now. I have a table, which is 20 billion plus table, more than 20 billion rows. And I have a query, which is a select from something, from this table where column equals something. And this query returns just 3 rows. It's a very selective query. 3 rows out of 20 billions. I have this 20 billion rows make 4.6 terabytes of data. I have 72 cores, enterprise edition, and its memory is not a big deal, it's 300 gig, but 72 cores. And now you need to estimate duration of this query. I don't have an index on this field, so SQL Server has to do what? Table scan or cluster index scan in this case. This cluster index has 5 levels, just additional information. And these are options here. Sorry. 9 minutes, 28, 44, or 124. Who is for 9 minutes? Just one person. We should be different, 28 minutes. Anyone? It's a bit few for 28. 44. 122. 122 won this competition, and we have some nulls also. But the answer is 28. I mean, just a funny thing, really 28 minutes. And here's the 28, really. 28 minutes. 72 million logical reads, 62 logical reads, 72 read-ahead reads. So it's a huge thing SQL Server does, 28 minutes. And the thing is, one can say, okay, we don't care. There are people, there are users who do not care about the speed. So I can run the query, go for lunch, and go back. So it's fine. I'm fine with 28, but you should not be fine with this, because this 28 means the following thing. So look at the threads. 72 threads doing a hard job to return 3 rows only. And you can see also how in Management Studio, Microsoft ordered this alphabetically. So thread number 5 is after 49. And it's really split the job, everything fine, but so hard job, so many CPU, just because you miss index. And of course, everybody here knows that we need indexes. But the thing is, you have to do this before table really become too large. If you have 20 terabytes table, it's very hard and dangerous to try to create an index. Who will guarantee that index will be created at all? If you have if you have enterprise edition, you can use rebuild online or resumable option to create this index. I know within 2-3 weeks, every day, a few hours if you have some kind of maintenance window, but it's very hard to do this. You can use filter indexes. But with filter indexes, you have some limitations that I cannot talk right now about them, but you have to be careful. And very important thing, there are many scripts like Ola Hallengren and other scripts for the maintenance everything. So very important thing about large tables. You should not maintain and manage large tables as the other tables. All the scripts that you apply for everything should not be applied for large tables. You should not rebuild, you should not even try to rebuild indexes, update statistics, with large tables with these common scripts. Yep.
Yeah, I'm thinking about the fragmentation point.
The fragmentation. So fragmentation.
Maybe you should distinguish between internal and external fragmentation.
Okay, the question was about the fragmentation. So I mean, here I advise do not rebuild the index, which means leave fragmentation as it is. So you should do something with fragmentation only if you're absolutely sure that fragmentation leads to performance problems. If so, then yes. Just because something is fragmented, you should not touch it.
What I was thinking about is that you have external fragmentation where the pages are in different places. And that was important in the old days when you had moving visible parts.
Okay, the comment was it's about for both internal external fragmentation. Generally, if you see clear numbers that a performance problem is caused by fragmentation, then yes. If not, don't touch it. Even if it's fragmented, it's 99% fragmented, don't touch it. So for large tables, if you need to scan large tables, you're in trouble anyway. If you just need to go with index seek, fragmentation doesn't make big problem. Okay. So the second thing, let's say we know we made indexes, we learn about indexes, we are professional, we do this at the right time. The next thing is how we write a query. So sometimes you have indexes, but SQL Server doesn't use them or doesn't use them efficiently. So here I have an absolute value function, and I have query, 2 equivalent queries. Who would write the first one? Only 2 of us? Just the 2 of us. Everybody will write this with minus? Come on. I mean, every day. So the first is intuitive, and why we have functions if I cannot use them. But in case that we use function, you see that SQL Server use 689 pages versus 7 pages. SQL Server cannot use this index efficiently. It needs to scan the entire index or to scan the table. And this is not a big deal for small and moderate tables. Who cares? 700 like this, 7 like this. You don't see difference. And that's the reason why this thing exists. If we switch to another table, this table has 100 million rows. And the same thing again. But this time, I use 7 seconds CPU time for the same thing. And the second is done automatically. So we have to be careful, especially for large tables. Something that doesn't hurt you with small and moderate tables can really dramatically change performance for large tables. And if you don't learn this with small or moderate tables, you will not learn, oh, now I will learn transfer SQL because my table become larger. No, this will not happen. So you just suddenly see huge performance issues. Another thing, and this is really stupid, so arithmetic operation. This thing we'll learn in primary school. You need to move 1 on the right side of the equal operator. And query optimizer does fascinating job sometimes. You write some poor query and then transform and make some optimization. You end up with great performance. But this, they even don't try to do this. So if you have arithmetical operation very close, you will have similar situation. And again, 60 versus 5. Who cares? It's good enough. Move to the big table. Look at now. 7 seconds CPU time just to return a single row. Because what SQL Server does is really take this index and increment 1 and then compare with the thing on the right side, which is stupid, but this is how it works even in SQL Server 2022. Intelligent query processing works like this too. And what does it mean? You will either have index scan of this small index, or SQL Server will think, oh, it's too expensive. I will even go to cluster index scan for something which is really trivial. Next thing, data type conversion. Again, people are just lazy. Many conversions are there because people are just lazy. You just need to mouse over user data type, and you will see it's a text. SQL Server will always try to convert text to number. And if your column is text and your parameter is number, you're in trouble. If it's opposite, you're not. And then people just like this. You know, if you like adrenaline and lottery, it's a great thing to put it in production in large table. But here you have, again, similar situation. You know, you cannot see from execution time the big difference, but in large table, you see difference. Again, 2 seconds of CPU time, I know, and parallel execution for nothing, just because I missed data types. So please care about data types or use explicit conversion. Do not let SQL Server to do implicit conversion for you. It will hard for large tables. So this is my advice for poorly written queries. The most important thing is the last sentence. If you want to have good performance with large tables, you have to learn Transact SQL. You should be good in Transact SQL. Neither Entity Framework or any other ORM mapper nor Microsoft will tune your queries. Even if they say, come to cloud, we will tune. No, they will not. Why? It's not in their interest. If you will pay more if you have more CPU. You have to learn Transact SQL, and you still need to tune your queries. They will put you a lot of weapons. They will put you great features you can use to tune your queries, but you're still in charge of query tuning. So you're responsible for that. Later, I will tune a single query all the time, 50 minutes. Very simple query, which is slow, and I will tune it. I will show you how to do this. Okay. Both things, indexing and poorly written queries, are related to all tables. But cardinality estimation issues with statistics are related to large tables only. So this is a large table, 100 million rows. Select from table where customer equal this. You see 245 rows I have, 245 orders made by this customer. In reality, SQL Server thinks it will be 32,000. It's not a big deal when you have a single table. But we do not have queries with single table in production. We have J, join B, join C, row number D, subquery that, group by this. And this is very complex thing. And if you have issues with a single table like this, when you join with other tables, it will be funny. I will join with other table, and this table is again, oops, something here is you don't see, is 1300. SQL Server has again overestimation with statistic, and now 2 overestimation with this join. Look at this, 42 million rows is expectation for SQL Server, and I have 248. It's a bit discrepant. If I add a third table, it will be more funny. 5 billion and 12 terabytes of data is estimation of SQL Server. I have 256. I will add the fourth one. I cannot read this number. This one I can, 30 petabytes. 30 petabytes of data we have in this SQL, and this query will run. And I have another one. And I broke this in Management Studio. I cannot even show a data size. It's minus something. And this number, I don't know if this number exists, this Avogadro, I don't know, what is this number? How many atoms you have in a liter of water? Something like that. And this query will work. And I will show you. Because this is a screenshot. I can put whatever I want here. This is a good thing, so you can believe. But this is, again, this is now really my query. So this is the first one. Come on. It's tiny. No, not this one. To show you that this ring, really, this is 27. No. Whoa, no, I'm in trouble. So I need to stop this presentation. Sorry for that. Okay, now you see this. You cannot hear both. So 27 terabytes, and you will see this minus thing. So just that really, in the latest Management Studio is the same. So it's not a big deal, of course, but it's funny. Oh, come on, come on. So minus 9 something. Okay, good. Now let's try to deal again with. Sorry. Okay, what SQL Server does? SQL Server, how SQL Server knows it will be 32,000? It makes statistic objects. Statistic object is used by Query Optimizer to find out which operator to use. When you write a query, SQL Server needs, like GPS, to create a plan for that. And for a large amount of rows, it needs to choose this operator. For a small amount of rows, it needs to choose this one. And SQL Server has to estimate which one to choose. And estimation is based mostly with statistic. And this is a statistic object, has header, density vector, and histogram. And in header, you see how many rows SQL Server has processed in order to produce this diagram, this statistic object. The second one, density vector, shows how many orders I have per customer in average. And the third is statistic histogram, where they find statistically significant values. And then everything which is statistically significant, when you have, I don't know, million orders in a single day or a single customer, you will see here. And this is where SQL Server see, okay, 32,000 rows will be there. And this is for large tables, simply say wrong. It's always wrong. Statistic cannot be accurate always, but for large tables, it's very wrong. And you will see now, why is this so? So SQL Server, when I write this query, SQL Server has automatically updated statistics. And there is this change in SQL Server 2014, where before 2014, we had to have 20% of data, then 20% of data has been changed. SQL Server automatically update starts. In 2014, they changed this with formula 1000 multiply cardinality of the table and square root of that. That means if you have 1 billion rows, after million changes. Not after million rows have been changed, but after million changes. Which means, so this is 100,000, that was old threshold, it's a new threshold. You see significantly smaller. For 100 million, you just need 300,000 changes, and now you will get stats update. It's more frequently than before. They try to overcome key ascending problem. I will mention this a bit later. So why I said it's not million changes? This is maybe not as known, but not many people are aware of this. If you change 1,000 rows 1,000 times, odds changes, price changes, stock changes, this is a million change. So you change 1,000 rows out of 1 billion, you get stats update. And you will end up more or less with the same statistic histogram. If you would change one row a million times, this is also million changes. Or if you change this 1,000 times 1,000 rows and you roll back the change, you did not touch anything, you did not change anything, you will get stats update. So stats update are more frequently than you might think. And what happens when stats is automatically updated? Of course, I still use Profiler, especially for conferences. It's not allowed in production, so nobody can use Profiler in production, but for conferences, it's fine. What happens? SQL Server will run this select stat, whatever. It is similar to update stats we do, and SQL Server will choose sample of data. 4% in this case, or 0.4% is used to create this sample. And this is exactly where the reason for root cause for the problem. For small and moderate tables, SQL Server will use the entire all rows. I will check all rows and I will make statistics. For large tables, they will choose sample rows. Why? They can choose between accuracy of data and impact, performance impact. If you would read 100 billion rows, of course, it is very expensive, and then they choose a small sample for that. And table, if you have 100 million rows, it could be 0.1% or even less than this. They just pick a sample, and that leads to huge overestimation. So I made some experiment. So I have a number of rows, 10,000 rows, SQL Server choose the entire table. 50,000 rows again, 90,000, it's already not used 100%, it used 90% of data as a sample. And you can see here first discrepancy. Estimated rows is what I see from statistics. SQL Server thinks it will be 73, in reality it's 27. So it's basically overestimation, 2.7. And then I go up to 100 million. In 100 million, you see that SQL Server overestimates 44 times. I don't have a proof for this, what I will say right now, but it looks for me, if there is a 0.1% of, if sample rate is 0.1%, they do not read every 1,000th row, because if you read every 1,000th rows, you need to load all pages. They just grab page, and then since I have, let's say we have order page there, and we have a 1st April 2020, and 1st April 2020 on this page, they somehow assume that all pages they did not read are similar, which is stupid when you have key ascending things or order date. 1st April 2020 will never happen again. It's a bit sad, but it's true. And then you assume it's somehow multiplied with this 1,000 and it's a bit corrected, and then you see huge overestimation. And that's the reason why in large tables you will have always overestimation, huge overestimation. And from your queries, from your workload depends how much problems we will have with this. And in my case, let's go back to my example. I have 100 million rows, and this is 32,000. It's overestimated 130 times. SQL Server overestimates 130 times. This is a statistic automatically get from, by default sample rate from SQL Server. The second table, SQL Server thinks that I have an order details table that for each order I have, in average, 1,300 items. And in average, I have 3.5 items. 400 times more. 400 times more, 130 times more, multiply this two with join, and then we are already in trouble. What does it mean now for this particular query? When I don't put a hint, SQL Server will choose hash join, of course, because it's a lot of data for 40 million rows, and I will end up with 11 gigabytes because I have an order by. It's not necessary, but people like to use order by when it's not necessary. And then this order by brings additional 11 gigabytes of data and 11 gigabytes of memory grant, just because SQL Server think it will be 40 millions, and I have really simple query that should be like this. Even in SQL Server 2022, it's the same thing. The reason why is statistic is wrong. So how to solve this? Today afternoon, I will show you how to work around this, how to make SQL Server, to push it, to trick it, to make this estimation better. But the root cause for this is statistic. I can update stats by using some higher sample rate. In this case, I pick it 50 and 20 because I will get the excellent estimation. You see here 218 versus 240. This is absolutely brilliant estimation for this table size. But it's enough to put, I know, 10%, even 5% for large tables is better. Do not go under 5% or do not go in under 1%. This is my experience. So the most important takeaway from this session, absolutely most important, do not let SQL Server to update stats object in large tables with default sample rate, ever. Don't let this 0. something. Just choose a higher sample rate. How high? That depends on, I don't know, your workload depends on your performance of your system, and then use persist sample percent option. This is available from SQL Server 2016 Service Pack 1. If you have 2014, unfortunately, you cannot do this. You need to work around this. If you don't put this, SQL Server next time, again, go with default sample rate. I can fix the problem with update, but default sample rate will go again. With persist sample, SQL Server will choose what I choose for with my command, and will respect this for the next time. This is absolutely must. And how much to choose? I have a huge table with more than 10 terabytes, and I have 5% there. And what happens if I choose the highest percent? I mean, Microsoft doesn't do this intentionally. I will make your statistic, terrible so that you have performance issues. There is a reason for that, of course. Update stats with default sample rate doesn't cause too much performance issues, performance overhead. Now, when I choose a higher, I need to take CPU from my customers. And then it's basically, again, you will increase CPU, you will increase I/O, and very important thing, you should let stats updates only then when you expect changes in execution plan. There are so many useless stats updates. You have a huge table, you have a simple, index sec, kilocup, and that's all. Very simple query. You will never have, and you don't want to have a different execution plan. Updating stats doesn't bring anything. Just take a lot of resources, but basically if you don't have expectation, if you have more or less the same stats histogram, you should not update statistics at all for these large tables. You just do it. SQL Server will do automatically because SQL Server doesn't know what is important for you, what's not. But basically you know, or at least you should know this. And then in that case, in order to avoid this thing, you can use no recompute. And this is again the second advice. For large tables, you need to have special treatment. You cannot just do it as all the other tables. You have to maintain them in maintenance jobs special for that. And for very large tables, I have, jobs, we update stats once per week or even per month. Not every day, because what happens if you let it by default, this is from one of the production systems, 47 minutes, it starts update. You see, this is single day. Single day, 9 times per day. 47 minutes takes, so almost half a day I have 100 gigs, 88 gig reserved for stats update, which ends up with the very same execution plan. All exec plans remain the same. I do it for nothing, and you block 100 gigabytes of memory for just nothing. So therefore, no recompute. So if you increase sample rate, then use no recompute to take care completely about the stats. Okay, any questions? Any questions online? This is the most important thing. And now, so this is something which I saw. I don't have a proof for that. If you have a column store index, maybe somebody from Microsoft can answer this. If you have a column store index in the same table, on the same column, even when I update statistic on non-cluster row store index, this is calculated differently. I don't see huge discrepancy. I see different numbers. I don't know. This thing is not documented. Whenever I have a column store, you can sometimes fix cardinality issues by adding column store, which is not used at all. So I don't know what happens there. It's not documented. So just take Hugo maybe knows.
I can shed a bit of light on that. Perhaps it's a bit too advanced for this session. Do you want me to do quite a quick explanation?
Yes, please. So Hugo will explain this.
When statistics are updated, SQL Server does a single pass over the data, trying to collect interesting points for the histogram as it passes over the data, but it never goes back. So the order in which it encounters the rows will affect the rows it marks as interesting.
And if you have a column store index?
It's unordered data, so the data is in a different order than when you read a clustered index or a non-clustered index.
Yeah, but I update stats against the IX1, very same statistic, but it seems that they read data differently. They take sample differently if column store is there.
Probably, but when they read from the non-clustered column store index, then the data will be read in a different order.
Yeah, but I update starts against which is underlying object of non-cluster, but it seems they read from column store.
Execution plan where it read data from?
No, I didn't. So the question, okay. Okay, thanks. So the Hugo's opinion is that SQL Server presence of column store index means that SQL Server will choose to read column store index because it's easier, faster, and then it will then create stats for that. But I did not check. I did not check the execution plan. Okay, the second very important thing, it's the most important from this one. The second thing here is to change default auto update stats asynchronously from false to true for database where you have large tables. But I will do this for all databases because it doesn't make sense to leave it false, and I don't know why it's still false. And I will demonstrate this now. Okay, I need to do the same thing now. Go here to demonstrate. Okay, here I have some, again, a table, orders table has 100 million rows, and I will perform some updates. This update will change 900 rows, something like that. And update is fast, okay? And I will update this. It's 945 rows, everything is fast. And what happens when I just do some stuff? We have new orders, and SQL Server at some point will update statistic. And I will simulate starts update with this. And as I said earlier, this is my query, which will update statistic. So as you can see, I have begin run, and I will update, I don't know, few thousand rows, 130 times, and I will roll back. I did not change anything in this table. It's a great thing. I can use it for next conference. So all fine here. So I will also remove this set no count, and I have a profiler to see that when I do this, SQL Server will have auto starts. Okay, good. Now I will update this, and what will happen now? SQL Server will compile this query and say, okay, statistic is out of date. Let me first update statistic, and then I will give you back to your query. And you see here, it's still not done. It will take about 18 seconds, I think. Now it will be done, 18 seconds, maybe a bit more. So 90 seconds. Now it's done, and you see here, oh, see, auto update stats. SQL Server has updated statistic. This is done synchronously. So I have a new statistic. Please wait. I will give better plan for you, and it gives me the same plan. This is about expectations. So what's the problem with this? I will repeat this now, and then after that, all fine again. So query itself is okay. Let's say that we have this functionality in an application. In the application, what we have, we cannot wait 18 seconds. We have some kind of command timeout, and I will set command timeout to 10 seconds here. So to simulate the application, I will just go here and set 10 seconds. And I will do the same thing again. So I will simulate execution. And now what will happen? I need 19 seconds. This is a 10 seconds. I will get timeout. Or bug in timeout. So, okay, I can survive one timeout, not a big deal. Let's do it again. Uh-oh, it's not updated. I cannot go out of this because this starts update is a part of the transaction that I roll back, and I cannot go out. I mean, I can go out. I can connect to the SQL Server somehow and to run any select which will update this, but this functionality won't work until this thing. And that's the reason why we need to set this flag. So when you go here and set this flag, which database is this one? To true, which is not default. And now I will repeat this thing again. So it will work. What happens here? SQL Server queue this and start and do this asynchronously. And then when you're done, then give me new statistic. This is a good thing. Or even for small tables. So just don't think about this. Put it. There are authors telling, this is basically better to leave it true. It's not. So if you know, in corner case, if your query will run 2 hours with this old statistics and maybe 2 seconds with new, then it might make sense to, to have this. But if I know this, I can update stats. If I have expectation from statistic, nobody stop me, I will update this. So just please leave it. I mean, many timeouts, many incidents in production are part of this because, default is very important thing. People leave defaults because if you are, you change default, you are responsible. If you change something, people don't want to have to be responsible for issues and then leave defaults. It's better to say it's a Microsoft thing than it's my thing. Okay, so just this is an easy thing. Auto create stats. This is a problem even more than auto update stats because there is no asynchronous auto create stats. And what is auto create stats? Whenever you have for the first time one column in filter. Let's say I have added a column updated on after in a large table with 1 billion rows. And then I have added this as in a query. This query is anyway fast, but I just want to have additional thing there. And when in this case, it's useless to have this, this column, but SQL Server, whenever some column appears for the first time in a filter, needs to create stats. And this cannot be done asynchronously, because asynchronously means I will use the old one before I update. There is no old one. And then you have to use to have a create stats. And I have because I don't have a table which is so huge in this, in my laptop. Please. This should be video, but it doesn't work. Oh, it works. Okay. This is now video, so now I can talk about this because it's anyway, it will work, I know. So this query will work properly, so everything is fine. This column is not needed at all. Just want to have additional filtering, and for performance point of view, it doesn't need to be there. I mean, it doesn't hurt, but just the fact that we have added it after, for the first time, SQL Server needs to create stats, and this create stats will take about 3 minutes. That means 3 minutes this functionality won't be available. So this functionality, I mean, in 24/7, 3 minutes, wow, it's a huge time. So I need to report when database is not available for, I don't know, half a minute. So 3 minutes is too much. And how to overcome this? How to tell SQL Server, I cannot tell, go asynchronously, you see? It's a compile time, 94 seconds. So 94 seconds, it's not 1/2 minute. But again, it's a huge thing. What can you do? You can, if you have a rollout, and if you plan to do this for the first time, just run some select against this column at any point before you roll out, and then you're fine. So you just need stats objects somewhere, somehow. If this doesn't work, again, this can take several minutes. If this cannot be done, you can make a clone of production database or copy of this database. Run this against some other server, and then inject the statistics by create statistics. Statistics is just a blob object. You can create it on another server, what I did here, and then basically result of this is create stats, and create stats just run, and this is instant information, instant command, and then you will have statistics in this table, and auto create stat will not block you. You should never remove auto update stats. I mean, you can solve this problem, but by setting auto create stats to false, but you should never do this. Don't do this. So just be careful when you roll out. Do some with this column, or when you create a large table, just make sure that all stats are created for all columns you have there, and you're fine. Okay. I will show you at the end if I have time. So for this, how to export statistics. But this is more important now. Querying a large log table. Let's say you have a select from very large table when you have a timestamp. You have a log table for a year, and you want to extract 2-3 days for further analysis. And this is a legacy query, and I have index and have timestamp. If you don't have index, you don't have a problem because this query will never run. So it's a good thing. So just remove indexes and you have no problems. You even doesn't make sense to try. Here, I need to, what SQL Server does in first case, if query is selective enough, and let's say we have a huge table that is selective enough, we will have a plan index seek on timestamp, and we will have key lookups on the other side. So there's something like this. This is index seek, this is my index, and this is a key lookup. So this will return 10 million or, yeah, 10 million rows. Microsoft doesn't format if somebody from management, so please do some formatting here, especially for all guys as me, so I cannot see. There's 10 million rows. That means 10 million rows multiply key lookup, and my cluster index have 5 levels. That means 50 million logical reads. And the entire cost of this query is here in key lookups. And then SQL Server can, at some point, decide it's too expensive, I will scan the table. If you scan a large table, you can forget. So SQL Server will never execute, it will execute this query after several hours if you scan the entire table or 6 terabytes. And what can you do? You can somehow introduce to force cluster index seek. How to force cluster index seek? You can try to find IDs which corresponds to this timestamp. This will not always work because you need to have some kind of ascending keys there. So if ID, FID from this date is definitely lower than FID from the right side, then you might do this. So I need to find the left border and right border of these two things. And if you are not sure about timestamp, you can go a bit right and left. So basically 10,000 more or 100,000 on the right side. And then to make this query more complicated with FID and this timestamp. And this will then put optimizer to use cluster index seek and range scan, which is a better solution. And you can see here in my example, it's 5 times faster. And sometimes can be a solution if SQL Server in the first time, in the first query, choose a cluster index scan, you won't be able to query this at all. In the second, you will be able to do this. So sometimes you just need to add IDs there to force SQL Server to use cluster index seek and range scan. If you don't do this, at some point there will be a tipping point where SQL Server say, okay, it's too much for me, I will scan the table. And for large tables, you should not see a table scan for a table with 100 million rows. Again, ascending key problem was a big problem until 2014. Now it's not so big, but it's not completely solved. Again, it's related to out-update stats. What is ascending key? If you have 100 million rows, before 2014, SQL Server did not update until you have another 20 million rows. So that means SQL Server doesn't see new rows there. Statistic doesn't see this. If you have orders from 2014, SQL Server, you did not have it at all. And it makes plans for a single row. Also, you have, I don't know, maybe million orders, and this is a big problem. By changing threshold from 20 million to 316,000 for 100 million rows, this problem is not so frequent as it was before, because when we have such query, I have a 100 million orders table, and I have added 300K on 2014. Everything in 2014 is not visible for statistics. And these two queries first return the entire year, and the second return only 5 minutes. Only 5 minutes for 2014. Both of them are out of histogram. Both of them do not exist for statistic update, doesn't catch them. And the way how it works depends on compatibility level. Compatibility level 110 and earlier, means before 2014, we'll see here 1 row. And that was the problem. 1 row, you will get index seek lookup, you will get memory for 1 row, and you have to deal with 300,000 row, you will have 10 dB spills, you see here, warning consult operator, and you're in trouble. The second is okay, I have 12. 1 is okay for 12, so I do not claim. I claim for the first one. What is different in 150 compat level or after in 120 already? So SQL Server makes differently, but it's hard-coded. In case of between operator or two predicates with and operator between, SQL Server goes with 9%. It goes and says, okay, it will be 9% of difference between actual number of rows and the rows in the statistic. So I have 300,000, basically 9 multiplied with 300,000, it's 27,000. It's basically what I have there, and this is the estimation for both. Even if you put option recompile with a second, for 5 minutes, you will get again 27,000. For the entire year, you will get 27,000. It's different. The good thing is that in most cases, this works good, because you usually do not query for 5 minutes. Give me all orders with last 5 minutes. But if you do something like this, you see here, overestimation, and this query should not be parallel because you return just few rows. It might be a problem also with this. The good thing with all this old new cardinality, you have a weapon to play with against this. You can use cardinality. You can use hint, legacy cardinality estimation, forced legacy cardinality, and choose one for this case, which I would choose in case of a second. So ascending key looks better, but it's not completely solved. And how can you make it better? You can use a filter statistic. Use filter stats, and you will get better here. Look at this. It's a great estimation. Filter stats won't be used if you have compat level 110. If you have later, it will be. Sometimes it won't be used, considered by optimizer. You will be disappointed. But in this case, I have a better estimation. I have an almost exact estimation. The second is good enough, and I have good plans. In first case, I got, I don't know, scan according to optimizer. This is a better plan, and the second is I don't have parallelism anymore, so I have better. So with filter stats, you can overcome this issue, or you can just update statistic manually. And the last thing I would show you is adding and removing identity. This is a common problem. You have a huge table, and you don't want to use identity anymore. You want to provide identity. And it would be nice if you go there, I don't need functionality identity anymore, please remove it. Oh, no. You cannot remove identity. Okay? And what is the way to do this? You create a new column, you copy the new column, or you create a new table. You create a new table without identity. You just then insert into, and let's go to code to show you this, because I don't have time. And come on, have 2 minutes more, please. Okay, so this one is my table. I think I have this 10 million rows table, but I'm not sure, so I need to create it again. So 10 million rows, I will populate this table. As you see, I still use itzig pengan get nums. Now there is a series, generate series. Thank Microsoft. I was criticizing this, but this time I really appreciate this, but I did not update this because I'm not sure if this will run against 2022 or 2019. So I will create, when this is populated, I will create another table, and this table is PK orders 2, and then this is the fastest way to do. I will introduce downtime because I need to copy this data, or if I don't want to introduce downtime, what can I do? I need to do delta chunks, and it's a lot of job for me to do this, and in 24/7, you should not introduce downtime. So basically, now it will take 15 seconds, and then you do this stuff, rename things, clean it up, and this will, again, so it's about 8 seconds. This laptop, by the way, has 46 gigs, so it's a huge thing, and 46 kilogram also. And I will repeat this to show you how can you do this more elegant. And if this would be 10 billion rows, this will take maybe several hours. So for 10 million, it's not a big deal. But I mean, now taxi driver has 10 million rows database. So 10 billion rows is not a big database right now. So we talk about, I don't know, very huge database. And this doesn't depend on database or table size. What can you do is the following. First, to create database and lose another time. So I will first rename my key, because in the second, I have created orders table, again, without identity, which is with PK primary key, which I wanted to name, and then I will use this functionality. Alter table switch. I can do this metadata thing, so please show to this structure. I will name it like this, but show, do not rebuild, do not copy, do not move. Just do like metadata, and let's see if it works. So this instant thing, and I'll just drop table orders. And now when I go to this, to just ident, so I have an orders table. I should have orders table, which is not identity. Come on, come on, come on. Show me that you do not have identity, and show me that you have data, because I can drop it and have empty. Table is there. So this is a great thing. It's absolutely brilliant thing. If you have a single table, and this is brilliant thing, if you have a table, there is a catch. If this key is a parent key in foreign key relationship, it won't work. If it's a child key, if it's a child table, it will work. And usually child table has more rows than the previous one. Or if it's a log table, it's absolutely brilliant thing. I hit the time, so if you have any questions, I will stay here another 10 minutes. And if not, then thank you very much for your attention and enjoy the rest of the conference.